Hey everybody, Root Beer here. We're looking at more of the 2015 Intermediate Math Contest. That's the CIMC. And we're up to question number 3. Okay, so hopefully you've had a chance to take a look at it and see what you can come up with. Remember, for the first 6 questions, part A, we only need our final answer, but it's a good idea to show our workings just in case we screw up and we can get some part marks, and that can certainly help us out. We want to get the best score possible. So what does question 3 say? In the diagram, line segments AB, CD, and EF are parallel. So here we have AB, CD, and EF. Okay. And points A and E lie on CG and CH. So here's C in the middle, and we've got spokes going out to G and H, and we've got A and E here. Okay. If the angle GAB is 100 degrees and angle CEF is 30 degrees and angle ACE is X degrees, what is the value of X? Okay. So before we go anywhere, how about we reproduce the diagram in our notebook? That way we can mark it up however we want. So G all the way down to C, H, C goes over to D, G up here, we have H right here, we had A up here, and A went out to B. These guys are parallel, and then we have E somewhere down here, going out to F, and that's parallel. So we have X degrees, we have 100 degrees, and we have 30 degrees here. Okay. So I'm noticing in here that I want the X degrees, and X degrees is sort of in this back portion here. And I start to think, well, how do I get X degrees? I'm only given information about the 100 and the 30, and I also have parallel here. So I start wondering, well, what if I complete this little circle in here? Okay? Then that means X degrees, along with these angles here, form a complete circle. So there should be 360 degrees on offer in here. Okay. So that's great and all, but what are these other two angles? What is ECD and ACD? Because once I figure out that, then I can say X degrees is the 360 for the total circle minus angle ACD and minus angle ECD. Okay? So if I knew those angles, I'd be home free. I can figure out what X is. So I start to think, well, what information do I have? I have the 100 up here, but he's sort of a line too far away. And I have a 30 down here. He's also a little too far away. But then I remember that these lines are parallel. So the next thing I'm going to do is I'm going to actually extend GC. Just a little bit. So AB is parallel to CD, and they both intersect our extended line GC. The only reason I extended it was just to make it more clear that CD is hitting GC. Okay? Sort of intersecting with it. Now there's a very important property that parallel lines have when they both intersect the same line, when they intersect a common line. And that's that their angle of incidence with that third other line is always the same. Okay? So we have A, B, and CD. They're parallel. They're moving along, and suddenly they hit GC. Well, AB sort of hits GC, and then a little while later, CD hits it a little further down the road. But since they're parallel, the angle that they hit GC, despite the fact that their intersection points are in different places, the angle is the same. Okay? We're going to use that to figure some things out. We're going to be able to figure out ACD from here. So, angle GAB, which I know, is going to be the same as this top angle here, which is angle ACD. We can also notice that angle CAB is going to be the same as this angle here, this, if we call this like JCD, that angle will be the same. But we're not looking for that angle right here. So we know GAB, that's 100 degrees. So suddenly I have angle ACD. I have that, I know that that's going to be 100 degrees. So I'm going to put that in there. Okay. And that worked so well at the top, I'm starting to think, well, couldn't I do it at the bottom? You know, I want this bottom angle here. Could that work? So we'll just erase our extended line here. If you want another look at that line, by all means, rewind to the video. So this angle right here, he should be this angle right here, the HEF. They should be the same. So I could extend that a little bit just to prove my point. But CD is parallel to EF, so that's how we write that. And they both intersect line CH. So, for example, angle HEF is going to be the same as angle ECD. Well, ECD is one of those angles that I wanted. So what is HEF? Well, I don't know. They didn't give me HEF. But they did give me CEF. So CEF and HEF, when we put them together, they just make the whole line CH, and a line has 100 degrees. Sorry, 180 degrees. So I believe these are called complementary. Are they complementary or are they supplementary? I don't want to write something silly. I think it's complementary, but we can just write this mathematically. The point is that they add up to 180 degrees. Okay? Maybe it is supplementary. Oh well, it's neither here nor there. The property is that they add up to 180 degrees. So if I want ECD, which I do, that will help me figure out X, I'm going to take it to be HEF, which, rearranging this last equation, is 180 degrees minus CEF. And I know what CEF is. It's 30 degrees. That's one of the angles they gave me. So ECD is 150 degrees. So this one in here is 150 degrees, so this is 150 degrees. Okay. So now I can figure out angle X. So X degrees is 360 degrees minus 100 degrees minus 150 degrees. And that's just going to work out to be 110 degrees. So X is 110. I believe we were asked for the value of X specifically, not X degrees. Yeah, what is the value of X? So there you have it, 110 degrees. So we're halfway done part A, which is just the final answer questions. In the next video, we're going to go over question number 4 on the 2015 intermediate paper. So hopefully you guys will join me for that. It'll be the very next video, and I'll see you then.